And then we've got our formula chart for reference that we'll come back and forth to. And then remember, this formula chart is posted in It's Learning in the completed notes folder and also in the assignment folder next to the review. All right, so number 30 and 31 are asking us to list the sequence by finding the arithmetic means. So again, on our formula chart, it says that means are the terms between two non-consecutive terms in a sequence. Okay, so we have two non-consecutive terms here and here. And then we've got a group of all of these blank terms, these are the means, and they tell us it's arithmetic. Okay, we talked about when we went over the quiz questions, and when we did this in our notes, you have to find in an arithmetic means question, you have to find your common difference, your D. In geometric means, which we're going to do down here, you have to find your R, your common ratio. Okay, once you find your D or your R, then you go back to this first term given, and then you just use that to continue the pattern. And then this is the kind of question that it checks itself at the end if you should get to that final value that is listed. Okay, so for arithmetic means, we need D. You have two options, and we did both in the notes. We said that you can use the equation, this one right here, okay, and work backward to plug in everything that we know. We know the first term, we know the last term, and we know the term number for the last term, and we work it backward to find D. Okay, but we said it's probably easier to have D already isolated like this right here, which is slope formula. So that's the formula we're going to use for arithmetic means. We're going to find D using this formula. Okay, so I'm going to write that out. It is the last term minus the first term over n minus 1. Okay, so I'm going to do some highlighting here. So the last term is negative 24.7. The first term is 12.4. Now, the term number. This is a sub 1. It's term 1. And then we've got 2, 3, 4, 5, 6, 7. So this is term 8. So the n here is 8. That's 8 terms in this list. We're filling in the middle 6. Okay, so for this one, we would do negative 24.7 minus 12.4 over 8 minus 1. You do not have to do this by hand. You'll get a calculator. You can use a handheld like graphing calculator or scientific calculator, or you can use Desmos. Remember when we take the test on Aware, the built-in calculator is the Desmos calculator. Okay, so let me get to my home screen here. So remember you can go here to alpha y equals to get it as a fraction like this. So I've got negative 24.7 minus 12.4. A mistake I noticed some people making, and they were getting errors in their calculator. There is a difference in the negative button and the minus button on this graphing calculator, on a TI-83 or 84, whatever you have. Okay, so this first one, you would have to use the negative and then minus here. If you use the wrong keys, you'll get an error symbol or an error message. Okay, over 8 minus 1. So that comes out to be negative 5.3. Okay, that is not the answer to this question, but it is our D value. It's what we need to answer this question. I'm gonna double check I wrote that down right. Yeah, negative 5.3. Okay, so the reason we need the D is because that is how we get from term to term to term what happens in an arithmetic sequence. What are you doing with D to create this pattern? You are adding it. Okay, so you are adding, and now it is negative. So what is actually adding a negative? Subtracting. So I'm just going to write it instead of as plus a negative, I'm just going to write it as minus 5.3. Okay, so I'm going to start down here with 12.4 and I'm going to subtract 5.3. So I start with 12.4 minus 5.3, enter, minus 5.3, enter, minus 5.3, enter, minus 5.3, enter. And I keep doing this to get the rest of my terms. Okay, so we fill those in that we've found so far. So the first one was 7.1, and then it was 1.8, and then negative 3.5, negative 8.8. Okay, and then we've got to do, I'm going to do it 3 more times. Minus 5.3, minus 5.3, minus 5.3. Because you can see that that third time, that last time I did it, it comes to that last term, negative 24.7. So that's what I meant when I said this is the kind of problem that ends up checking itself at the end. So this one was negative 14.1 and then negative 19.4. And it did check out. We got to this one at the end. So I'm going to put a little check because I know I did it correctly. All right, so we're going to do the same thing here. This is our A sub 1. And then this is 2, 3, 4, 5. So this is A sub 6 this time. So this time my n will be the 6. My first term is 2. And my last term is negative 17. But I'm using that same formula. Okay, so that is negative 17 minus 2 over 6 minus 1. Okay, to get my D value. So again, you can do this in your head, you can do this in your calculator. So negative 17, I'm going to do the alpha y equals to get the fraction again. Minus 2 over 6 minus 1. So negative 3.8 this time. In the graphing calculator, to get it as a fraction like that, you do alpha y equals, enter.
Oh, no, like it gave me.
Oh, it gave your answer as a fraction. So if it gives your answer as a fraction, you can use it. It's fine. Or you can go to math. And right here, the first two are fraction and decimal. So if you want it to be a decimal, you hit 2, enter. Or just 2, actually. And if it's given as a decimal and you want it as a fraction, you would hit the 1. Okay, so I already forgot our answer. Got distracted. All right, negative 3.8. So this is another one that is negative, so that means we are subtracting. And I knew we were going to be subtracting because we started with a 2, a positive 2, and we ended with a negative 17. So obviously it's decreasing. So to get from term to term to term here, we are subtracting 3.8. And we start with 2. So 2 minus 3.8, enter. Minus 3.8, enter. Minus 3.8, enter. I think that's all of them because we end with the negative 17. Okay, so that's how you get all of your terms that you need to fill in for this sequence. So that was a pen up here, blue. Negative 1.8. Negative 5.6. Negative 9.4. And negative 13.2. So that is arithmetic means. You have to find D. So when you see this, arithmetic means, you should think find D. And you can just look on your formula chart for this formula. Good with that? those. All right, geometric means, okay, similar concept, except this time we need to know R. Okay, in our notes, we did this by using this equation, the last term and the first term and the term number, and working it backward to find R. Okay, to get R by itself, we divided the first term over, and then to get rid of a power, we had to take the root with that same power as the index of the root. Okay, and it seemed to, most of y'all got it, but sometimes that was confusing. So I went ahead and put it on here, solved for R, with those steps already taken, showing that we're doing the a sub n divided by the a sub 1, and then we're taking that root number. Okay, so it's on the formula chart with R isolated already, solved for R. Okay, so you will just get that formula from the formula chart. That's what we will be using. Because when it says geometric means, we have to find R. Okay, and R is the n-1 root of a sub n divided by a sub 1. Okay, so we have to identify these pieces. So this is a sub 1, and then there's only 2 terms here. So that's 2, 3. So this is a sub 4. So in this problem, our last term is 13.5. That's a sub n. It's going to go here. Our n is 4. It's going to go here. And our first term is -4. That's a sub 1 for here. Okay, so for this particular problem, having some issues with my pen here. The connection, it's lagging a lot. If y'all are on your phones, please put those away because that tends to interfere some. Okay, so we've got 4 minus 1 as the index of the root. Okay, and then that would be 13.5 over -4. Okay, you can do this all at once in the calculator, or you can break this down. You can go ahead and type this. We know 4 minus 1 is 3. You can go ahead and type it as the cube root. You can go ahead and do this division. It doesn't matter if you do it all at once or in pieces. Okay, but that will look like this. When you need a root other than a square root, remember, you go to the math menu on your graphing calculator, and there is a cube root for the 4th option or an xth root. That means you can type in any root you want. So if it's not a cube root, you could type in the 4th root, the 5th root. If you want to type in 4 minus 1 there, just like that, that's fine also. Or you could go ahead and type it as a 3. It's not going to matter. And then it's 13.5, which you can just type in divided by for the fraction, like this, or you could do, like if I did this as the cube root, and then I could do that alpha y equals to put it as a fraction, and you can see both of those are going to work out and give us the same answer, typing them in either one of those ways. But it's -1.5. Okay, that is R. Now, in the arithmetic series, we said D was how we got from term to term to term. Okay, we were at plus D, plus D, plus D. But this is geometric. Geometric is a different type of sequence. It is not adding a number to continue the sequence. What is geometric sequences? We're multiplying by a number continually, so that R is what we're multiplying by. So we're multiplying by -1.5. So times -1.5 times -1.5 times -1.5. So that's what we need to do to fill in these missing pieces. So we're starting with -4 times -1.5 times -1.5 times -1.5. times negative 1.5 to check itself. Oh, actually, I went one too many. So it did check itself. I just did one too many terms. That's okay. So the negative 4 times the negative 1.5 was positive 6. And then positive 6 times negative 1.5 was negative 9. And then negative 9 times negative 1.5 was positive 13.5. So you can see if it alternates between negative, positive, negative, positive. That tells you right there your R must be negative because that's the only way to alternate back and forth between positive and negative terms. Okay, so we're going to do the same process here. This time, our first term is 10. Our last term is 0.016. And what term number is that? This last term. This is a sub 5. It is the 5th term. So the n is 5 here. So this is going to be the 4th root, because it's 5 minus 1 as the index, of 0.016 over 10. Okay, so I'm going to go back to the calculator. We said the 4th root, because it was 5 minus 1, of 0.016 divided by 10. And that comes out to 0.2. So positive 0.2 is our R. So again, remember that is how we get from term to term to term. Using that R, we are multiplying by it. So times 2, or excuse me, I wrote 2. It's 0.2. It's not here. So times 0.2 times 0.2 times 0.2 times 0.2, etc. Okay, so I'm going to do that. Here we started with a 10. So if we have 10 times 0.2 times 0.2 times 0.2 times 0.2, okay, and we will fill those in, and it did check itself at the end there, right? 0.016, that's what we should end up with, and we do. So that gives us confidence that we calculated that R correctly and that we continued the pattern correctly. So this was 2.4, 0.08, and then 0.016. Any questions about means? That's arithmetic means, find D and continue the pattern. Geometric means, find R and continue the pattern. Good? Okay. So the next group of questions here says to state whether each sequence is convergent or divergent. So remember, we talked about this in part 1 of our notes if you needed to go back and review it. Convergent means that it approaches some specific number, okay? Graphically, that would look like it's approaching a horizontal asymptote. Divergent means that it has no limit. It goes up to infinity or down to negative infinity, or maybe it oscillates back and forth, but it doesn't approach some specific number, okay? There's no limit. Okay, and we talked about arithmetic series and sequences are divergent because they're linear. A line goes up forever or down forever if it's a negative slope, right? So it's not approaching an asymptote for sure. So I can tell you any of these that are arithmetic will definitely be divergent. So can you recognize, looking at these 4 problems, can you tell me if any of those are arithmetic? Which one did you say, Madison? That is correct. Okay, because remember, this is in dn plus c form. When it's in that format, that's like mx plus b, right? A line. Okay, that format, that is definitely an arithmetic sequence. Okay, so this is arithmetic, which it didn't ask us to identify that, but that's going to help us know immediately that this is divergent. Because it is a line. It is, this particular one has a positive slope. Our D is a positive 7, so it's plus 7, plus 7, plus 7, plus 7, right? All the way up to infinity. Is there another one here that is arithmetic? That's the only one in arithmetic explicit form, but there is one here that's in recursive form. Remember, what did recursive mean? Recursive was when you used the a sub n minus 1, meaning the previous term, right? So if I look at this one, that means the previous term. So they're saying take the previous term plus 4. This is arithmetic. This is saying plus 4, plus 4, plus 4, plus 4 is how you continue the pattern. Y'all see that? And if you don't recognize it, actually write the sequence. Say, okay, well, they told me it starts with 9. And then that would be the previous term plus 4, plus 4, plus 4. That's supposed to be a 1. I kind of curved it. Etc. This is obviously going up forever to infinity, right? Because it's arithmetic. It's linear. So this one is also arithmetic. 34 was in the explicit formula. This is the recursive formula. But both are arithmetic, so both are definitely divergent. Now, geometric sequences and series, we said, can be convergent or divergent. It depended. Remember, graphically, we said, because geometric are exponential equations, and we said you could have an exponential that looks like this, right? And it grows infinitely, so it has no limit right there. You agree? As x goes to infinity, it goes up forever. So that's divergent. But we said some exponentials do converge. Like what if it came this way? Okay, and it converged down to the horizontal asymptote. That would be convergent. Do y'all remember what we said, how we knew which one it would be? If it would be divergent or convergent? We said it all depended on R. The absolute value of R was either going to be less than 1 or greater than or equal to 1. If it was greater than or equal to 1, we said it would be divergent. But if it was less than 1, we said it would be convergent. Okay, so looking at 36 and 37, these are both definitely geometric. They're both in the format of a sub 1 times r to the n minus 1, aren't they? That's geometric. Okay, so what part of them is r? What part of 36 is the r value? The -2. And what part of 37? The 1/2. So one of those is going to be divergent, one of them is going to be convergent, because one of those, the absolute value is greater than 1, and one of them is less than 1. Do y'all see that? The absolute value of -2 is just 2, right? And 2 is greater than 1. That meets this criteria, meaning that it will be divergent. That means we cannot find the sum of an infinite, this infinite series. This one, though, the absolute value of 1/2 is 1/2, right? And 1/2 is less than 1. So that means that this one is convergent. That means if we were asked for the sum, we would be able to find the infinite sum because it converges on a specific number. Because if we were to continue this pattern, it's times 1/2, times 1/2. The number keeps getting smaller and smaller and smaller. You keep getting smaller and smaller and smaller. It's converging. Does that make sense? Okay, so that's convergent versus divergent. And then this last section on the last page, we had one on the quiz like this as well, that we went over yesterday. When you are asked what type of polynomial model could be used to represent the sequence, this is where you're finding the differences. And this is where we said, once you find the constant difference, where all the differences are the same, that tells you what type of model it will be. If it is the first difference that is constant, that means it's a linear model, which is an arithmetic sequence. If it's the second difference that was the same, it means it's a quadratic model, because it's the second power. If it's the third difference that's the same, it will be a cubic. If it's the fourth, it will be quartic, etc. And then it doesn't have to be a polynomial. It may not be a polynomial model. Like this sequence right here that we just talked about, this is a exponential model, right? The variables in the exponent. You would never get a constant difference. Okay, so it doesn't have to be a polynomial model. But if you find a difference that is constant, then this tells you what type of polynomial model it is. So we're going to find the first difference between these. Okay, so remember, you're finding the difference. You can think of it, some people can see it straight away. They can say, oh, 2 to 5, that's +3. Okay, 5 to 8, that's +3. Okay, if you don't see it straight away, you subtract backward. You say, okay, what's 14 minus 11? Oh, it's 3. 17 minus 14. Oh, that's 3. So this is the first difference, isn't it? That's constant. So what model is this? This is linear. This would be an arithmetic sequence. Okay, so we're going to find the first difference here. See if it's linear as well, or if we'll have to do a little bit more work. So we ask ourselves, what to get from 8 to 13, we have to add 5. To get from 13 to 20, we have to add 7. And that's 9, 11, 13. Definitely not the same, so it is not linear. So then I go on, I find the second difference, the difference of the differences. So to get from 5 to 7, that's +2. That's also 2, 2, 2. So this one is the second difference that's constant. So what's the model? Quadratic, good. Okay, we're going to try on 40. So that would be +23. When you start getting into those larger numbers, you may want to use the subtraction, actually, the difference, and that's 111. Okay, and then 447 minus 134 is 313. 1124 minus 447 is 677. And 2,375 minus 1,124 is 1,251. Definitely not constant. So we're going to find the second difference. So 111 minus 23 is 88. 313 minus 111 is 202. 677 minus 313 is 364. And 1,251 minus 677 is 574. Still not the same. So I will try a third difference. So 202 minus 88 is 114. 364 minus 202 is 162. And 574 minus 364 is 210. Still not the same. Okay, so then we are going to do a fourth difference. So 162 minus 114 is 48. And 210 minus 162 is also 48. So we finally got to a constant difference on our fourth difference. So this one is what we call quartic. All right, last but not least. All right. So sometimes with the negatives, it's a little harder to tell. So you can just use the -8 minus -6, that's -2. Okay, and then -6 minus -8 is +2. And then 6 minus -6 is 12. And 34 minus 6 is 28. And then 84 minus 34 is 50. So definitely not the first difference. Okay, so 2 minus -2, we know that's 4. 12 minus 2 is 10. 28 minus 12, we've got our 16. And then 50 minus 28, 22. Still not the same, so we'll try the third difference. 4 to 10 is 6. That's also 6. Also 6. So this time it is the third difference, which we said is cubic. So there you had one of each example for the 4 that we went up to. I don't think we will see one that goes higher than the fourth difference, but that's the process. Does that make sense? Okay. All right, so that is the end of that last page of the review, where all of the other videos are going to be posted as well. Let me stop this recording real fast. Or actually, before I stop it, just remember this is due tomorrow for a quiz grade. It's due in your class period. You're taking the test tomorrow. So make sure you have this completed. Go back and watch the other videos if you have questions on other pages, and bring this completed on time for a 100 quiz grade.